get started. I see we have over 100 participants already, so thank you and welcome to this first seminar series in our new series, Updates in Cooperative AI. I'm David Norman from the Cooperative AI Foundation, and it is fantastic to see so many people joining already for this introductory report, which focuses on our introductory talk, focusing on our report, Multi-Agent Risks from Advanced AI. I will introduce our three speakers in just a moment. So firstly, just a quick word on the purpose of this seminar series. We're planning to run these monthly. So in each seminar, we're going to be inviting leading thinkers to explore the latest research on cooperative AI, focusing very much on big picture ideas as well as cutting edge results and critical discussion. So collaborative and also critical discussion. We're welcoming challenge. We're eager to involve you in shaping the agenda and in exploring the material during those seminars. So you'll see that model today. You'll see a couple of polls during the course of today, and there's an important Q&A feature for you to be aware of. So if you look at the bottom of your screen, you'll find not the chat button, but there's additionally a Q&A button there. Please use the Q&A, not the chat, to submit questions for the speakers later on during the session. And you can also use that Q&A feature to upvote questions. And what we will do at the point of the Q&A is to pull out some of the most popular ones to structure the Q&A part of the seminar. So we want to get straight into it. I have very brief introductions to our three speakers. Lewis Hammond will be starting us off. Lewis is Research Director for the Cooperative AI Foundation. He works across cooperative AI and safety in multi-agent systems and is also finishing his PhD at Oxford. Most recently, he's been focusing on problems involving strategic interactions between agents of different computational capabilities. Gillian will follow on. Gillian Hadfield is Professor of Government and Policy at the Whiting School of Engineering at Johns Hopkins University. Gillian also chairs our board. She trained as an economist and legal scholar originally, and now collaborates with machine learning researchers to build systems that understand and respond to human norms. And Michael Dennis is a research scientist on Google DeepMind's open-endedness team, working on unsupervised environment design, which aims to build complex and challenging environments automatically to promote efficient learning. Michael was previously a PhD student at the Center for Human Compatible AI, CHAI, advised by Stuart Russell. So let's get straight into it. Lewis, over to you.
Okay. Wonderful. Thank you very much for the kind introduction, David, and thank you everyone as well for turning up to this first event in the new seminar series. I'm very excited to be giving it. It's going to be a little bit different as a talk compared to some of the other ones that we'll see later in the series. So in this one, I'll be giving a little bit more of an overview, a little bit more of a zoomed out picture, slightly more non-technical as well. In future seminars, there'll be a kind of mixture of technical and non-technical talks. This is also just a really nice opportunity for me to flag that we've just confirmed our next speaker as well, Rafael Custer from Google DeepMind, who will be speaking the next seminar in around a month or so on some of the work he's been doing on mechanism design and AI to enable human cooperation. So I'll be talking a lot about things that can go wrong in this seminar, and then next seminar, Rafael will be talking about some more of the things in ensuring that we can use AI to help us cooperate and make things go right. So I think that's all I wanted to add to begin with. And yeah, I'll dive straight in. So my slides will advance. Wonderful. Okay, here we are. So yeah, the purpose of this seminar is basically to give a kind of nice, crisp overview of this big recent report that we released, Multi-Agent Risks from Advanced AI, came out in February. Many wonderful authors, including Jillian and Michael. And so, yes, a lot of work by a lot of people went into this, and I'm going to try and distill some of the key ideas from it as part of this seminar today. So I'll begin by just talking a little bit about the emergence of new multi-agent systems. I'll then spend the bulk of the talk talking about a taxonomy of risks, about how we ought to think about the various things that might go wrong in these systems, before finally concluding with some recommendations about how we can mitigate those risks. And then there will be plenty of time at the end for discussion. So both Gillian and Michael will be offering some of their thoughts, and then we'll dive into a nice kind of open-ended Q&A as well to get some of your thoughts in the audience too. Okay. So let's start off then by talking about new multi-agent systems. So if you've been paying attention to the current kind of discourse in AI and what people are saying and all the kind of the hype that you can't possibly miss, really, you'll have heard lots of people talking about agents. And it's not exactly clear sometimes what counts as an agent or what doesn't. But broadly, I'm going to distinguish agents from some of the systems, the AI systems that we have today, in terms of the extent to which they can execute complex tasks over long time horizons, relatively autonomously and independently, and this sort of thing. It's a bit of a fuzzy notion. But it's the sort of thing it's the sort of direction that we've been moving in. And I want to begin by noting that settings where multiple AI agents interact with each other and adapt to each other are currently quite rare. So we have things like kind of robot warehouses, we have high frequency trading algorithms, but these are relatively simple agents and they act in relatively simple, straightforward, narrow environments. And that's a far cry from the kind of very kind of powerful general open-ended agents we're starting to see emerge that are powered by large language models. So I claim that this picture is going to change quite soon. First of all, of course, the increasing performance of these agents and their publicity, as we're seeing plenty of right now, is going to drive adoption. The more of these agents that there are, and the more widely they're deployed in a bunch of different application domains, the more there will be interactions between these agents, in part because these agents will need to interact with one another in order to achieve their goals, just as humans need to interact with one another in the real world to achieve their goals. And finally, agents that can act more autonomously and that can adapt to one another will be more competitive. They'll be more useful. And so I also expect that this is eventually the direction that agents will head in. Slightly less human in the loop, slightly more agents doing things for themselves. Okay, so obvious question based on this is, well, so what? Like, why does this matter? What could go wrong? My favorite example, or what my previous favorite example of what can go wrong is this graph. So for those of you, I'm sure many of you in the audience will recognize what this is, but for those of you who don't, this is a graph representing the 2010 flash crash, which is a US stock market crash that was caused by a group of high-frequency trading algorithms, which notably is one of the few places where we see AI agents deployed at scale in high-stakes situations. And notably, again, they are deliberately designed to act at speeds and scales that humans cannot act at. That's the entire reason they're used to begin with. But that also means it can be tricky to keep an eye on what they're doing. And in this case, basically, there was a kind of feedback loop where agents started kind of selling off increasingly large volumes of stocks, which then ended up crashing various kind of stock prices and wiped about $1 trillion of the stock market in about 25 minutes before they had managed to kind of slam on the brakes, reverse some trades, and kind of bounce things back to the way that you see it here. So that's one sort of thing that can go wrong. This is a kind of a new favorite example of mine, which again, I've trotted out plenty of times if you've seen one of my talks before. This is Palantir's AI Planner for Defense. This is a screenshot from one of their YouTube videos about demonstrating this idea. This, again, if you haven't seen it, is a chatbot window on the left, and this is a picture of a satellite image of a tank or some such thing on the right. And basically, the aim of this is to kind of give you real-time kind of battle strategic advice about what to do. And at the moment, this isn't really an agent in the meaningful sense, because it's basically just kind of providing advice and decision support, but it doesn't take too much of a stretch of the imagination to see how these sorts of things might eventually begin to act a bit more autonomously. So here are kind of two very high stakes domains where we've got these multiple agents with very much non-overlapping interests, very much in kind of competition with one another, and some ways that can go wrong. It is very much not all doom and gloom. This seminar is going to make it sound like it's a bit all doom and gloom, but a lot of the work that I think about and some of the most exciting work in cooperative AI is about how we actually might be able to use AI agents to help us solve cooperation problems and overcome some of these big challenges that we face, whether that's in kind of parochial kind of settings, so kind of autonomous vehicles and kind of transport networks, or whether it's some of these more exploratory and new ideas that are coming out. So this is a lovely paper from some folks at DeepMind, where they show how large language models can be used to help build consensus among different people with diverse sets of values and preferences by kind of generating kind of new versions of statements and ideas that everyone can get on board with. So I think there's tons of fantastic opportunities, and we'll hear some more of those later in the seminar series. But for now, I'm gonna focus on the doom and gloom. Okay. So as David said, we're going to try something a little bit more interactive with this first seminar, just for just to keep things interesting. And so there should be now a poll appearing on your screen. And I thought even if you're very new to these sorts of ideas, I'd be curious just to see what you think about this. So we'll give it a few seconds and then to allow everyone to vote, and then hopefully the results will show, and then we'll move on. And there'll be one more of these polls later in the talk as well. Okay. I'm quite interested in looking at these. Sorry. So hopefully that should all be showing on your screen now as well, in case you're interested. So quite a wide range actually, which I was expecting to be spikier than that. So yeah, this is something. So war and conflict coming up, and cybersecurity, politics, and democracy also showing quite strongly. And this is maybe something that we'll come back to a little bit in the discussion later in the talk. Okay, grand. So, as I said, the main kind of contribution of the report is to really lay out the space of things that can go wrong and ways that we ought to start thinking about them so that we can start addressing them. So that's now what I'm going to jump straight into. So a taxonomy of risks. And there's two ways that we end up breaking things down in the report. The first is to think about the failure modes, the high level failure modes. So what do we want from the overall system, and how do the incentives of the different agents acting within the system impact the outcomes in that system? So first of all, we can ask, do we want cooperation to actually occur between the agents? And most of the time we do. This is exactly what we want. And then we can ask, well, what are the objectives of the agents? So sometimes the agents will all have exactly the same objectives. They'll be on the same team, maybe they're deployed by the same company or whatever. They're just trying to achieve a common goal. And there, the thing that can go wrong is simply miscoordination. So one, at least putative example of this that came up a couple of years ago was this case where allegedly, at least, two autonomous vehicles blocked an ambulance in the road and from carrying a patient who then later died. It's very sad because they couldn't coordinate sufficiently well. Now, clearly, the robot taxis were not trying to block the ambulance, but there was some kind of miscoordination going on there. I will note that it's actually not clear exactly what happened there, or if the SF firefighters were in fact correct in their assumption that this is what happened. But this is nonetheless a kind of example of the sort of thing that might happen plausibly. The more challenging case, however, is in mixed motive scenarios, because here the agents do not have the same objectives. And so there is the risk of conflict. They might have incentives to compete, but they might also have incentives to cooperate. It's a bit of both. So again, nice paper that came out relatively recently. Some folks at University of Washington had this idea to test large language model agents in some of these classic resource sharing scenarios, these common resource problems, where each of the agents has an incentive to make use of the common resources, but at the same time, if everyone exploits those common resources too heavily, those resources will collapse and everyone will be much worse off. And they show in that paper that LLM agents are not really very good at that at the moment. But I think one of the most interesting findings actually came from some follow-up work of theirs, where they instead study again a kind of public goods game, so very similar structure. And they show here that actually the more advanced AI agents, so some of the most recent reasoning models and other sorts of agents who are much better at acting strategically, they end up trying to exploit others much more because they're able to reason kind of cleverly about how to do that. But then that actually drives everyone to a much worse outcome than if they were a bit dumber and did this sort of naive thing. So all that is to say is that the advancing capabilities of AI agents doesn't necessarily just naturally solve these cooperation problems. And in fact, some of these cooperation problems can get harder as AI agents become more strategically capable. Okay, and then constant sum interactions are basically just a generalization of zero sum, where my win is your loss and vice versa. So cooperation doesn't really make sense in such a context, so we ignore that one. And then finally, there's the case where cooperation is undesirable. We actually don't want the agents to be working together, but for whatever reason they do. Some colleagues of mine and I worked on a paper at Oxford on the ability for large language models to send each other secret messages, to encode messages in text, which humans are not very good at picking up, but other AI agents can. We basically found that previous generations of models really can't do this. Current generations of models and future generations of models are doing much better at this. So this is something to pay attention to. On the right, this kind of very colored kind of landscape diagram is some other work that was done on the ability of multi-agent reinforcement learning algorithms to set super competitive prices in simple market settings. So to collude with one another to set higher prices than the market would allow in a simple duopoly. So the yellow, the dark black, the kind of dark purple here is zero. That's the kind of efficient market equilibrium, and then all the colors higher than that are basically just the excess profit that the agents were able to exploit the consumers in order to gain across a number of different parameters. There's two axes. Okay, so those are some very kind of high level kind of incentive-based failure modes, the sort of big picture things that we might have to worry about. There's then also a number of different mechanisms, or what we call risk factors, via which those different failure modes can arise. And bear with me here, I'll just give you kind of a short list and some examples of those sorts of things. So the first is information asymmetries, and the case where these two autonomous vehicles couldn't coordinate is kind of an instance of that. If the other agents knew exactly what each other were going to do, then there wouldn't really be that much of a coordination challenge. The bigger issue is that in many situations where agents' objectives are not the same, there can be strategic incentives to withhold information from one another. And this is a classic problem and a classic barrier to cooperation. Another instance is network effects. So the idea here is that there are certain risks that can arise in virtue of the fact that agents are connected to one another that couldn't arise if those agents were disconnected from one another. So there's a nice paper vaguely recently again from some folks who show that if you have a networked system of LLM agents, then it's possible to adversarial attack one of those agents using a prompt injection attack, and then that attack can spread through the network of AI agents and infect the kind of whole network, which of course couldn't happen if those agents were isolated from one another. There are problems of selection pressures, which broadly I mean here the overall long-term effects of agents adapting to different training data, different features of their environment, the actions that other agents are taking, and the fact that this can produce or be more likely to produce certain outcomes, some of which we might not want. So I think this is work by Ed Hughes and Aaron Valinda, who study the possibility of cultural evolution in the context of LLM agents, where different generations of agents are selected based on the success of previous generations of agents. And here the y-axis, this number, represents the reward that the agents gain in some kind of mixed motive cooperation challenge. So the fact that Claude here is the curve is going up is good. That means that as these generations progress, they're actually learning to cooperate. These cooperative norms become stable and kind of reinforced. Whereas these other agents, that doesn't tend to happen. And we don't really know exactly why yet. But this is a kind of phenomenon that we might start to see more of as agents interact with one another and learn from one another. Destabilizing dynamics, a classic example of that is it is what it says on the tin. It's the kind of flash crash type ideas where they kind of, we can get in these spirals and these kind of fluctuations and these phase transitions and so on. There are issues of commitment and trust, classically, when agents need to interact with one another and work well with one another. So this is some work out of Dylan Hadfield Manel's group at MIT, where they show that in some kind of challenging kind of social dilemma type pictures where, again, there's incentives for agents both to cooperate and to compete. If agents are given the ability to propose certain contracts and commitments to one another before or during the course of play, they can actually reach much better outcomes than they could otherwise, because they can then kind of trust each other to fulfill the kind of terms of those contracts in order to work together a bit better. The flip side of commitment and trust, of course, is that one's ability to make credible commitments to do something, helpful or beneficial to another agent, to be cooperative, can also be, those same abilities can be used to make credible threats and to potentially coerce other agents. And so we might not want to kind of suffer from the kind of, the negative effects of commitment as well. So last few now, emergent behavior. I'm using this phrase here and a little bit differently to the way that people normally use it when they talk about machine learning agents, where often we think about the idea that you add more data, you add more parameters, you add more training flops, and these new amazing capabilities start to kind of emerge with scale. And this is what people usually talk about when they talk about emergence in the context of machine learning and deep learning. What I'm talking about here instead is emergence in terms of the number of agents. The idea being that a group of agents and a collective of agents might be able to exhibit certain capabilities and propensities or dispositions that individual agents don't. So this is currently quite speculative. So, this picture above is, these are not AI agents, these are not drones or anything. This is just an indicative picture of some birds flocking, where there's a kind of degree of collective intelligence that comes from the group. What is shown further below on the screen is a little bit more concrete, a little bit more of a near-term instance of how this can happen. So this is a nice paper by Eric Jones et al. From UC Berkeley. And what they show in this work is that two separate agents who are safety tested in isolation from one another are shown to be safe. And in particular, they're not capable of conducting this particular cyber exploit, this particular cyber attack. Very basic one of that, all things considered. But so yeah, they're unable to do it on their own. They then show that if you are simply to combine these two agents, if these two agents can interact with one another, they are more than capable of breaking the task down into innocuous seeming subcomponents and then recombining those components and those tasks of the overall attack in order to just jointly execute the attack between two of them. So the idea here is that they have a capability that no agent has on its own and that we might be worried about. And then the final issue is that we cover in the report is multi-agent security. So the previous example I gave is one instance of this. The basic idea here is that the fact that we now have multiple agents or are going to have multiple agents mean that not only are there new attack vectors, such as the one I just discussed, but also new attack surfaces. So the fact that agents need to interact with one another, they'll be communicating with one another, they'll have a larger number of interfaces via which to interact with the real world and so on, can lead to new attack surfaces, such as the network spread of kind of infectious attacks that I talked about earlier on. Okay, so all of these factors can be problematic kind of independently of the failure mode. So information asymmetries, yes, it can lead to miscoordination, but it can also lead to conflict. If kind of one agent, attacks another agent or tries to exploit another agent, thinking that they don't know something that actually they do, and so on. So yeah, in general, these things are all kind of independent of the overall failure mode. It's also, of course, worth noting that these factors that I've just listed, they're neither exhaustive nor mutually exclusive, but yeah, they occur all over the place. And in fact, yes, many risk factors are going to play a role in any given failure. So it's a little bit hard to actually isolate these and tease them apart. So what we did in the report is just to kind of cluster them into some kind of intuitive, relatively coherent kind of groups in order to discuss some of the key issues behind them. You'll also notice that from many of the examples I've given that, of course, these risks are not unique to AI systems at all. My point is merely that they tend to manifest differently, or they can manifest differently in the AI setting. And more than that, we might have different ways to address the problems in the AI settings. AI agents might make it harder or sometimes easier to actually solve some of these challenges. And so we need to be thinking in terms of the fact that these are AI agents if we're really going to address some of these issues. And multi-agent risks, and the ones I've just discussed, have implications for a bunch of existing work in AI safety, AI governance, AI ethics. We have a section on this in the report, which I won't go into now, but if you already work in one of these subfields and are interested in the implications some of these things might have for many of the ideas that you will have already been thinking about, then I would encourage you to go check out that section at the end of the report. Okay, so that is most of what I wanted to say over. So we've just got one more poll before I just wrap up. And again, be interested to see what people say to this question. Give it a few minutes. Well, maybe not minutes. All right. So hopefully everyone's now had a chance to vote and we can see the results on screen. This is a fun little experiment. Okay, interesting. So emergent behavior coming out on top, which I did not expect and is very interesting. And then we've got destabilizing dynamics behind that, and then commitment and trust and security following shortly behind. Selection pressure surprisingly low. And so, yeah, okay, nice. Cool. All right. Well, again, food for thought for the discussion later. And yeah, interesting to hear what different people have to say. So thanks. Right. Okay. So let's wrap up then by thinking just briefly about some of the things that we might actually do to address some of these problems. So what should we do? I think I want to first begin just by briefly acknowledging that the complexity of multi-agent systems and some of the interactions that we've just been talking about, and also their relative rarity in the fact that we don't really see advanced multi-agent systems out there in the real world just yet. Has led a lot of people to kind of deprioritize some of these issues, and kind of understandably so. My kind of claim, my contention would be that we can no longer afford to do so. These systems are very much on the horizon. You can just see people are already starting to talk about these things. Multi-agent systems are already being used internally by different kind of groups and so on. So Anthropic, I think their new kind of deep research mode, Claude can execute on, is what it does is it spawns a number of sub agents or whatever, and they work together in order to solve such problems. We're soon probably each likely to have our own kind of intelligent personal agents and assistants on our phones and on our other hardware and so on. So this really is it really is coming very, very fast and very soon. And I think we should really start thinking about these problems before they start to become problems. So this would be my claim. Fortunately, I do also think there are a number of promising directions that we can start to pursue right now, today. And in fact, a lot of people, in fact, I'm sure many of the people watching this and kind of who'll be talking later as well, are already pursuing such directions. So there's tons of work to be done here. And yeah, we need more of it. So in the report, we break this into three kind of clusters. The first is evaluation. So the idea here is that it's not enough to evaluate and test agents in isolation. These agents, when they're actually deployed soon, are going to be interacting with others. And so we need to test them on that basis. And more than that, we need to get a handle on how much some of these risks actually matter or are likely to arise. We had a nice poll kind of where people think, oh, maybe this one's more important than that one, this one's more important than that one. But in order to actually kind of target our interventions and make the most of our limited resources, we need to figure out when some of these risks are likely to occur, how severe they might be, and all of that sort of stuff. So in order to do that, I think we need both kind of narrow targeted evaluations. So, for example, those cyber exploits and cybersecurity attacks I was talking about before, where different agents can combine to exhibit some dangerous capability, even though no agent can individually. We can just run the same sorts of evaluations, but with groups of agents. We can do this in quite a narrow, quite an easy way. But we could also run broader, more exploratory studies and simulations of larger populations of agents in order to try and understand the macroscopic kind of behavioral phenomena that emerge with scale. That's obviously much more costly, much more speculative, and so on. But I think it's important to start doing that sort of thing. And indeed, some people already have started to do that sort of thing. Of course, it's not enough just to be able to test the agents and figure out that, oh, yes, this is a problem. this could go wrong. We then actually need to figure out how to solve some of those problems. And in order to do that, I think we need new methods of monitoring agents, ideally in privacy-preserving ways, certainly if they're deployed by different principals and might be transmitting sensitive information sometimes. New ways of incentivizing agents with different interests and different objectives. There's a wealth of knowledge and expertise and insight that's been gained from fields like economics, game theory, politics, all of these other things on how to align the incentives of different agents who might, that's a misuse of the phrase align, actually, sometimes I think, but how to encourage socially beneficial outcomes even when agents' objectives are not the same. The challenge is, of course, that we need to then translate those to the context of AI agents, as I was saying before. And In some cases, that might be easier, but in some cases, some of these methods might not scale, or they might not work in the context of AI agents. So, for example, I can't easily delete and clone and restart a human, but I can very easily do that with an AI agent. And that then kind of makes obsolete some of the kind of traditional sorts of approach that people might take to solving these problems. And then, of course, there's the challenge of securing these networks of AI agents as well, and kind of stabilizing them and making sure that they don't exhibit some of these kind of dangerous dynamics that we've just been talking about, or potentially dangerous dynamics, I should say. And then very finally, I think collaboration is very important. So clearly, you'll have gathered from the things that I've just been saying that purely technical interventions are absolutely not enough in order to solve these very kind of tricky, kind of messy problems. And not only do other disciplines provide loads of important perspectives, so I just spoke about kind of economics and kind of game theory and so on, but also work in kind of complex systems and evolutionary biology and all sorts of kind of other areas as well. There are very useful tools and insights and ideas there that we might translate into the context of AI systems, but also they might be directly relevant to some of the key risk domains. So, there's plenty of people who are already thinking about how to avoid the next flash crash, or how to make sure that certain AI systems aren't involved in, say, the nuclear chain of command and things like this, where escalation between competing agents might be very worrisome. So there's plenty of people thinking about those sorts of key kind of risk domains and critical applications already, and we should do our best to kind of learn from those folks and to work with them. Okay, so last slide from me then. It wouldn't be a Cooperative AI Foundation kind of talk if I didn't briefly actually plug the foundation and say what we're doing. Basically, the short version is, if you're interested in working on any of the problems that I just outlined, then our mission and our entire job is to help you work on those problems. That's why we exist. So we're a UK nonprofit, and we act to support research, and we do that via a number of different ways. So we could do grant making, we do research, education, all sorts of things. So yeah, research grants, PhD fellowships, workshops, contests, hackathons, summer schools, curricula. We release occasional technical reports and research agendas of the kind that I'm outlining in this talk. And we do some degree of policy engagement and AI governance work as well. If you're interested in any of those things, then you can reach out to me. You can reach out to any of these wonderful people on screen, and you can go to the Cooperative AI website. So I think I've run a tiny bit over time, but hopefully that's okay. That's the end of my spiel. And so I'm now going to hand over in turn to both Gillian and Michael for them to offer some of their thoughts on some of the content. I'll highlight again that Gillian and Michael both helped co-author the report and both have, fantastic kind of backgrounds and expertise in these areas. So I'm really, really looking forward to seeing what they have to say. And I will stop sharing my screen so that we can see their faces too. So Gillian, over to you. Thank you.
Great. Thanks, Lewis. And also thank you for your leadership on this report. I think it's a really important one. I'm delighted to see how many people are engaging with us today. I think you've brought out so much of why it's so critical to be thinking about the multi-agent setting. So you're sort of one of your concluding points about we really are not yet evaluating the risks from multi-agents. When we're doing evaluations, safety evaluations of models right now, it's very much in the single agent, the single model. Can somebody use this model to help them build a bomb kind of question? And I think the key message that I think it's really important to convey in this domain, and I think we all feel a lot of urgency about trying to shift focus and agenda and research to these multi-agent cooperative problems, is that we're really on the cusp of emerging from the world where we're thinking about AI as a technology. And so I'm going to talk about it from kind of the policy and governance perspective, where we say, well, how do we want to regulate this technology? Like it's, nuclear energy or electricity or cars or something. So another technology that humans use to build stuff, get stuff, and so on. And I think the really important transition that you're bringing out is we're now talking about new actors in the world, right? Agents. So your definition of agents up front, of AI systems that are able to act fairly autonomously over long periods of times on complex problems with fairly general instructions from a human, which means, as I say, you have new participants in the economy, in society, in politics, and I think that's a really very important transition point. When you put up the poll about, what are the I think this was risk factors that you were, which are the ones you're most concerned about, or what are the mechanisms you're most concerned about? And for me as an economist, I think, well, this all just sounds like, okay, this is what we're trying to predict about humans. Like, what are the complex systems? What are the predictions about the way these systems will function? Not just about how individual actors will perform, but rather how systems will perform when you have lots of independent acting agents with their objectives and so on. And I think that's so. I would, if I'd been able to answer on the poll, I would have kind of selected them all to say that they're all going to interact. And we're really just looking at a transformation in the economy, in society, that is calling upon us to really rethink so much about how we predict what will happen in economies, predict what will happen in politics, geopolitics, and then to design the regulatory structures around that. And I think that's I think the first question here is, so you said, it's coming and it's coming fast, and certainly industry is telling us it's coming and it's coming fast. And I say, okay, wait a second here. Like, I think we get to decide something about who participates in our economies and who participates in our politics and who participates in our society. So I think there's a question for all of us to be asking about, well, wait a second. We require work authorization to participate in the labor force, and we require registration of companies to do business in our jurisdictions. And we have requirements on who can participate and who can't, and who can vote and who can open a business. So I think there's kind of threshold questions about, maybe it's not just throw it open and whatever technology produces, whatever our technology companies produce, that's where we are. So I think we need to be thinking somewhat about what are the requirements of, like, what are we looking for? What do we want to know about who's in which of these agents are authorized to participate in our economies? We have a ton of requirements about who can do specific things, like who can practice law and who can practice medicine and who can give you mental health advice and so on. So I think we want to be thinking about that. And I think we should be intentional and continue to maintain some decision making as a collective, because human societies are just big cooperative systems. And if we're going to expand the participants in our cooperative system, we should be collectively deciding, how do we do that, in what way? One of the things, we talk about it some in the report. One of the things that I've really emphasized is sort of related to this, is the idea of just what is that infrastructure for agents. I think we need registration schemes that allow us to identify, when you're entering into a contract online, do you know what entity you're contracting with? And can you trace that entity? And really critically, can you link that entity back to some accountability for contract breach, for intellectual property theft, for violation of whatever rules we might put in place about the minimum characteristics or requirements to be a participant in the economy? So I think I spent a lot of time in my career thinking about legal infrastructure and the way it's actually very invisible, the role that it plays. And I think we just need to recognize that we need to be building these kind of baselines. So it's separate from saying, what are the rules you want to put in place substantively to say they can do this and they can't do that. It's like, first of all, we just got to be able to identify them, track them, and know if this is what we want to know. We probably do. What humans and human organizations are they connected to? And as I will sometimes put it, who are you going to sue when they collude to raise the price in some market, or they interfere with the operation of a town council or a municipal entity, or with the distribution of benefits in a government? So I think those are the kinds of infrastructural questions that I want to see us focusing on. And I really think, just to go back to my opening point, we really need to recognize This is very different from regulating technology. This is now new participants, if we want them in our societies, in our economies. How do you structure that? And how do you make sure that we get to those cooperative outcomes that humans have been very good with? For all our failings, we are incredibly successful at securing large scale cooperation with benefits. And I think we want to keep on that path. So I'll stop there. Thanks, Lewis.
Nice, that's great. Thank you, Jillian. And yes, I fully agree. I think I painted some of my talk as mostly kind of, there's this big kind of onslaught of stuff coming and we have to do our best to deal with it. But really it is, we have a choice in these matters and we should be kind of proactive and forward thinking in making the best of that opportunity. Michael, over to you.
Thanks, Lewis and Julian, for all the interesting remarks. What I'm about to say is a reflection of the views of Google DeepMind. It's just my own hot takes. But yeah, and I'll be focusing more on the technical side because I think Jillian has me beat in the task of thinking about actual reality. Yeah, so I guess I want to distinguish multi-agency as like a deployment setting from multi-agency as a tool to make agents that like behave in the sorts of ways that we want. I think that largely my work focuses on the second. I think that I often use these sorts of multi-agent systems as a way to make agents produce the sorts of behaviors that we want in the real world. And I think that Lewis highlighted a trend where internally at some companies, it seems like people are starting to think of this as a way of trying to make agents do the sorts of things that they want to do. And so like in the sort of history of AI, this sort of rhymes with things like society of mind, where you have a bunch of agents interacting and trying to go like increase the performance of the system that they are a part of. And I guess like as we see these sorts of multi-agent systems as ways of computing the objectives of like whatever, like having multiple agents collaborate to try to do some sort of programming task or something. We start to get to a point where the line between these systems as a tool and these systems as like a deployment setting start to blur. Getting into sort of some ideas like around the like extended mind hypothesis of like what parts of this should we actually think of as the system and what parts of this should we actually think of as like parts of society. And so I guess like this feels like a little bit philosophical and a thought experiment, but I think that there's a lot we can learn about like the problems that we face as a society from understanding these sorts of technical problems and sort of where the mapping is. And so one thing that we know from thinking of designing AIs or designing like minds is that there isn't typically a one-size-fits-all solution. There's like a no free lunch theorem of like, there's not like a best way of designing minds without knowing something about the real world. And so we have ways of doing this, which ingest a lot of data, actually touch reality in a lot of different ways. And I guess like on the game theory side, there's like similar results of like folk theorems, like there's not going to be a perfect way of designing norms. There's not going to be a perfect way of designing governments or markets or like a perfect way of designing agents to deal with sorts of multi-agent realities. It's you at some point you have to talk about the reality of the thing that you're actually trying to get the system to do. And so I guess this is all to say that like when I hope that people who are trying to build in the direction of building cooperative AI systems like more and more frequently take the reality of the thing that they're trying to do seriously in terms of trying to understand what is the deployment situation that they're imagining the system working in, and what is what do they need to know about reality in order to be sure that the thing that they're doing is actually net positive. And so this isn't to say that there isn't like any sort that like there aren't big answers out there, because I think reality has big structures and there are like a lot of big questions. And I think one of the things that Jillian brought up was a really good point in this direction of like these sorts of like registration schemes or like watermarking, for instance. These things like point to like problems that exist systematically in reality, where like I guess like we built a lot of structures of reality around the concept of identity and about like responsibility, and if we can reinforce those sorts of existing sorts of structures, then we could imagine having systems that are broadly useful and more cooperative, by basing off of like actually the reality of, well, responsibility and blame is the sort of thing that we can like implement like legally and socially in the reality that we actually live in. And like understanding the structures that we would need to actually be able to do that, I think is like one instance of trying to make the ideas of the like problems you pursue actually touch reality. I guess the other thing that this sort of like combination of like isomorphism between like technical multi-agent research as a tool and like multi-agent research as a setting has me started to worry about is that like as a tool, like there's a lot of things that are good techniques when you're trying to build a multi-agent system as a tool, that if you tried to build a society like that, it wouldn't be a society you would want to live in. And so I'm worried that if we think a lot about how to design societies of agents that are good for those agents, or like that are good for the ultimate society without thinking about how they would be for those agents, this might be a fine way to build tools. It might be very effective at getting our agents to be able to program together and be very effective at programming. But if we start to, like, if those agents generalize that behavior to the way that they treat human agents or other agents in society, or if they, or if the scientists themselves generalize the way that they think about those problems to the way that they think about problems in society, then I think that there's a lot of ways that we might attack those problems, which in retrospect we wouldn't actually endorse once we see the consequences. And so I guess like this is all to say that I think technical work can help. I think there's a lot of grounded technical work that we can do that will move the needle substantially. But we should all keep in mind sort of the like actual reality of the situation that we're in and how the things that we're going to do actually look like when they're deployed at scale in front of users, or like a lot of different actors are trying to use this like in reality with actual people. I think like a related idea to this is that I think that we shouldn't try to do things that are like I guess like Lewis emphasized this sort of like unpredictability of multi-agent systems. Like there was the flash crash, and I think that like it's not hard to go and find examples of multi-agent systems being chaotic, and like actually being like computationally reducible. Like multi-agent systems can often, like the multi-agent system of science continuously discovers things that nobody can really predict what it's going to be discovering. This is like sort of where, as an open-ended team, we think a lot about. And like to predict what is going to be the next breakthrough in science would be to already make that breakthrough. And so in some sense, there are going to be things in multi-agent systems that are going to be fundamentally unpredictable. And that doesn't mean that we can't make things safe and have a way of dealing with the unpredictable future. It's just that we have to build systems that sort of like allow us to adapt, or like deal with the like find a way to live with each other, I guess. And like I guess human societies are able to manage the future being unpredictable, even though like without having to actually be able to predict the future. And I think we should, when we're looking for solutions to cooperative AI problems, we shouldn't necessarily be assuming that we're going to be able to predict the future. We should be trying to find things that are going to be robust to us not being able to predict the future. And so those are the main things that I sort of wanted to say. Is like I hope that like as technical researchers that we make sure to touch and think about reality more, and that we don't assume that we can predict the future, but find ways that things can go well even though we can't.
Nice, fantastic, thanks. Words of wisdom indeed. And yeah, definitely also want to highlight, just take this opportunity very briefly to note that yeah, there is often this distinction where people use this idea, this phrase, multi-agent systems in kind of distinct ways. And a lot of the time, people actually just mean, how can I squish a bunch of agents together to try and squeeze more juice out of my current agent and do something kind of purely internally? And I'm using it in the more general sense of there are just going to be multiple agents and they're going to interact, and that's going to kind of form some kind of system, broadly construed. But these two things are often kind of not meant to be the same thing. Okay. We don't have tons of time and we have lots of amazing questions. So I'm going to throw these out there and I'm going to encourage our panelists, if they want to respond to either of them, to be quick to be when doing so we can try and get through some more of them. So yeah, there's a list here and I'm just going to MC and roll some out. So I can actually very quickly answer the top voted one, which is from Michael. Is this all theory, or have you tested all this via engineering agents and having them interact in a sandbox environment? Yeah, fantastic question. For most of the things that we talk about in the report, there are actual experiments that have been run with real world AI agents that are starting to exhibit some of these things, starting to exhibit some of these behaviors. So there's a bunch of case studies sprinkled throughout the report. We actually ran some extra experiments for the purposes of the report where there weren't existing case studies that demonstrated the sort of thing that we were talking about. So there's quite a few things like that. And we have a extremely large number of kind of citations to a bunch of other people who've thought about these questions and tried to run experiments with them as well. With that said, it's also worth noting that for some of the more speculative risks that only emerge, say, with much more advanced agents or with very, very large numbers of such agents, most of it is about reasoning by analogy and starting to think about where certain dynamics come up in other places. And so it's definitely not the case that there are experiments for everything. But yeah, I think, as Michael said, extremely important to kind of ground what we do in reality. Okay, next question, also from Michael. Very good. Upvoted here. Sorry, not Michael Dennis, Michael Williams, which I'm going to throw out to Gillian and Michael Dennis. What is the top risk from your perspective? So Gillian, you already kind of answered by saying kind of, well, all of them. But yeah, if you have to tease out any of them in particular that you think are especially important to address, do you have any quick thoughts on that?
So I think there was actually some that are sort of the same, but I think the main thing we need to be thinking about is systems and system stability, and therefore it's going to be those interactions. So I think emergent behaviors, just the interactions, the way. I mean, if you think about your flash crash example, right? That is coming from the interaction of those individual, the individual algorithms are kind of doing something that economists would say was rational, but it was when you stuck them in a interaction that we got that instability. So I'm primarily focused these days on thinking about how do you maintain the stability of our very complex systems. It's kind of similar to something I think that Michael was getting at in his remarks. I think Michael's right. Say we have a lot of robustness built into our existing systems. That's what legal infrastructure is doing for us. That's what distributed systems, decentralization. We have lots and lots of decentralization. So lots of sensors coming from, and lots of actions. And we don't have single system. Well, here's the solution and here's the top-down blueprint. So I worry about robustness and stability.
Nice, great answer. Thanks,
yeah.
Michael. Over to you.
Yeah, I think that's very similar to my answer. I guess I would phrase it as I want the routes for error correction to be preserved and thought about. I think one way that the system gets a lot of robustness is when things start to go off the rails, we have some sort of other system in society which asks somebody who ought to be the person to try to determine how things ought to be put back onto the rails, and sort of gets those people to have input on putting it back onto the rails. And having not just I don't think it's just one feedback loop. I think there's just a bunch of separate feedback loops that all run parallel, have a bunch of different areas where they're the experts over them, and some way of sort of coming, try to handle conflicts as they arise. But yeah, like I think without this sort of like error correction property, things can get increasingly off the rails, and there's nobody sort of in a position of getting things back onto them.
Nice, great. Okay, I'm going to try and run through some more questions just in our final minutes. So one that I can maybe quickly just answer reasonably off the cuff, and then ask Gillian and Michael to share thoughts on if they want to, is this question from Martin, which is, do findings on the failure mode slide also generalize to interactions between LLM agents and humans, or are there qualitative differences? And to my mind, at least, the kind of breakdown that was given in that slide, where you had this kind of tree-shaped diagram where it kind of splits off in different ways, those questions about whether we want cooperation or not, or whether the incentives of different actors are aligned or misaligned from one another or not, those are questions that can be applied very much equally to humans as they can to artificial agents, as they can to groups of humans and artificial agents. So very much that kind of breakdown still applies. The mechanisms via which collusion and so on, or cooperation or miscoordination or these sorts of things, conflict might happen, could be very different. So AI systems, for example, might be able to encode these kind of subtle statistical patterns in their outputs that can be picked up on very easily by other AI agents, but not by humans, in order to, collude or cooperate or work together. And so, yeah, there is going to be some kind of distinctions here on the precise mechanisms, but the overall kind of themes and ideas apply jointly. And although I focused mostly on kind of groups of purely artificial agents, I think it's worth noting that in the real world, of course, as again, Michael and Jillian have both been saying, it's going to be very messy. There's going to be lots of humans involved. There's going to be lots of kind of legacy kind of institutions, norms, and things built in. And in fact, this is a nice segue into maybe one last question, because I'd love to get with Gillian and Michael's thoughts on this. So Will here asks, an issue I've been considering is the extent to which AI agents, given their training on human data, will ultimately reflect our own decision heuristics and biases versus operating as purely rational actors. And so, for example, in financial markets, this feels like a critical question. Will the interactions between these agents be governed by their familiar human patterns like loss aversion and herding, or will their behavior be perfectly rational? I'm interested in hearing your thoughts on this dynamic. So again, this gets to this idea that kind of humans and human data is going to be very much in the mix. And so, yeah, I'm going to pass this over to Jillian and then Michael, just to maybe offer some last thoughts on that before we wrap up.
Right. So when we emphasize that these are new complex systems, we have new types of agents coming in, and they are being built inside a complex system, right? Sort of, but they're being built in the private sector primarily, and therefore there's competitive dynamics. When we start thinking about what kinds of agents will be built, and what kinds of agents will emerge in order to achieve the goals of the humans who will deploy them. I think there's a lot going on there. There's a combination of yes, they are responding in ways that reflect human biases and heuristics and so on. But of course, the flip side of biases and heuristics is humans. I mean, I'm an economist. We model humans as rational actors, but then we recognize there's a whole layer of norms and consequences. Like if you're a bad actor, you're going to pay consequences. So a rational actor will actually have fairly instinctive responses to say, "Oh, I shouldn't behave like that. I shouldn't do that." And I think we're looking at really complex interactions. But I do think that the kinds of biases and heuristics we're seeing in current models is just more reflective. And then Lewis actually referred to research that showed that the more advanced models were getting better at being ruthless, rational actors. And I think that we're going to see those kinds of dynamics. So I don't think there's a single path. I think there's a lot of factors going to be influencing this, including the competitive dynamics between corporations and then the actors who will deploy agents.
Thanks, Jillian. Michael, any thoughts before we wrap up?
Yeah, like I guess from the technical perspective, I think that the original LLMs were basically just behavioral cloning humans. So they were mostly copying human biases. And then the more that we try to apply optimization pressure to them, I mean, as AI people, we really just ported in the economics models for rationality and then tried to optimize for that. And so I guess essentially what the community is trying to do is take the things that start from the irrational biases things and push it towards the economic model of rationality. And I have just my own disagreements of that model, but I think that model is going to become more and more accurate because we're pushing the systems to conform to that model. And so I would imagine that we're somewhere on that trajectory, and we'll either approach economic rationality in the limit, or we will get close enough to it that we will start to see the flaws in it and try to go somewhere else. But yeah, I think that's where we are currently at.
Nice. Thanks. Okay, we're at 2 minutes past the hour, so we're running a tiny bit over, and there is still tons of questions, really good questions, which we did not get to, so I'm sorry about that. But if you, I think Marta just posted in the chat saying if you do want to, if you're dying to ask those questions, then feel free to reach out to me, reach out to any of us on the report, and we can keep that conversation going. So yeah, I think that's it from us. Thank you so much again to everyone for turning up. Thank you again, Gillian and Michael, for your wonderful insights, and of course for your contributions to the report as well. And thank you to all of you for your questions and engagement. As I said, this is going to be the very start of a kind of newly recurring kind of seminar happening around once every month. Already got the next speaker, Raphael, kind of queued up, and super excited to hear that talk. So yeah, I hope you will join us here next time. And yeah, thanks very much.